Welcome to Joey's dynamic programming tutorial. In this video, let's solve the problem of best time to buy and sell stocks from Leetcode. The problem is simple, and if you are in the early stages of solving dynamic programming problems, then you should watch this video till the end. And if you have crossed the beginner stage, then there is nothing wrong in brushing up the basics. With a heart full of hope and a resolve to move up, let's see the problem statement. You are given an array of prices where any number over here gives the price of the stock on that very day. For example, 3 from the array gives the price of the stock on day 4. You need to find out the maximum profit which you can obtain by buying the stock on one day and selling it on any subsequent day. So for example, if you choose to buy the stock on day 3 at 5 and sell it on day 5 at 6, then you obtain 1 as the profit. But is this profit maximum? I certainly hope not by glancing at the array. So let's find it out by solving it using dynamic programming. But before that, if you haven't subscribed to my channel yet, then do hit the subscribe button and hit the bell icon too, as that way you will be notified whenever I release new videos like these in the future. Alright, so you see that I put down the prices array over here. Now think for a moment which other parameters we need to take into account. Number 1 will be the profit which we are chasing, and number 2 will be the minimum price that we need to take ahead, as you must be knowing that you can make maximum profit only from a stock by buying it as low as possible and selling it as high as possible. So to track these two components, let's create two more arrays, one for profit and another one for the buy price. Now, what value should I populate in this cell of the array? Buy price. Since it represents day 1, so it can't be anything other than 7. Okay, on day 1 I'll have to buy the stock at 7. Now since I can't sell on day 1, as I can only buy on day 1, therefore my profit on day 1 will be 0, isn't it? So we have just solved our first subproblem. We move to the next subproblem. Over here, the price of the stock on this very day is 1. So let's see what happens when I sell my stock on this day. The buy price 7 when subtracted by 1 will give minus 6. Now, since I'm chasing maximum profit, would I pick 0 or minus 6? On any day in all my senses, I would pick up 0 over minus 6. Alright. 0 means no loss, neutral, and minus 6 means loss. Thus I populate 0 in this cell from the previous subproblem, and like I said earlier, to obtain max profit I'll have to pick up the buy price as low as possible. So what is minimum between 7 and 1? 1 obviously, hence I populate 1 in this cell. Why I have populated 1 in this cell? Because I am taking the minimum buy price ahead, and that's what this array is tracking. So this cell says that if we were given just two prices for 2 days, 7 and then 1, I would have made 0 profit. That means I wouldn't have bought the stock at all. Moving to day 3, we have the price as 5. So if we buy the stock at 1, which is given by our previous subproblem, and sell it at 5, then the profit we obtain will be 4. Now between 4 and our previous profit, or the running profit, 0, which is maximum? 4 obviously. So I put 4 in this cell of the profit array. And what will be the value in this cell of the buy price array? It will be the minimum of 5 and 1. Which will be 1 obviously. To remind you, we are interested in buying the stock at a price as low as possible, and that is why we are taking the minimum price ahead. Now we move to this cell The price over here is 3. So we subtract 1 from 3. 1 is the minimum price that our previous subproblem, this cell of the buy price array, gives. So when I subtract 1 from 3, I get 2. Alright, so we are chasing the maximum profit between 4 and 2, which is maximum. So the maximum will be 4. So I remove 2 from here and I populate 4 over here. What will be the value that I'll populate in this cell of the buy price array? It will be the minimum of 1 and 3, which will be 1 only. Now we move to the next cell. Here the price is 6. So I subtract 1 from 6, I get 5. Alright, so what is maximum between 4 and 5? This 4 is given by the previous subproblem. This 4 is the maximum profit that we can obtain till here, till this subproblem. So between 4 and 5, which is maximum? 5 obviously. So I populate 5 in this cell and let me remove 5 from here. Now I'll populate the value in this cell, which will again be 1, the minimum of 6 and 1. So let me populate 1 over here. Now we move to the last cell. Over here the value is 4. So I'll subtract 1 from 4, I'll get 3. Now which is maximum between 3 and 5? It will be 5. So I populate 5 in this cell. And between 1 and 4, which is minimum? 1 obviously. So 1 gets populated in this cell too. Alright, so we have filled this entire profit array, and this last cell over here is going to give us our maximum profit, which is 5. We obtained this 5 when we subtracted 1 from 6 over here. And this 1 was the minimum price this subproblem gave us, but it traveled from all the way over here. This also means that if we buy the stock on day 2 and sell it on day 5, then we are going to obtain the maximum profit, which is 5. And we have found our solution using the dynamic programming approach. You'll find the GitHub link to the Java solution of this problem in the description box below. I hope you enjoyed watching this problem. I hope you learned something from this video. Do let me know if you have any doubts related to this problem in the comment section. I promise I'll answer them within 24 hours. I look so much forward to help you with programming and algorithms. Thank you and take very good care of yourself.